Oh, got interrupted there for a minute. 8y minus 32 minus y equals 17. So just once I substitute it in, then I've got a negative 2 times everything because it was negative 2 times x, so I need to distribute. And now I have gotten rid of the parentheses by distributing, and I just need to combine like terms. So this is 8y and minus y, so this is 7y minus 32 equals 17. Add 32 to both sides, and I have 7y equals 49 divided by 7, and y equals 7. So once y equals 7, then I can plug that back in to one of my equations and figure out what would x equal. So I'm going to plug that into the top one. X equals negative 4 times 7 plus 16. So that's negative 28 plus 16. So negative number is bigger. That means we're going to end up with a negative number. And then find the difference. 28 minus 16. Negative 12. So x equals negative 12. The two equations below are a system. So what would the value of m be in order for this system to have no solutions? So this is a very conceptual question. It's just asking you, what do we know about equations when they say they have no solutions? Well, no solutions must mean that there's never a point that they share. So that must mean they mean maybe parallel. So to be parallel, you can see that means that one is not steeper than the other. They are both the same steepness, which means that the m's have to be the same. So the value of m would have to be 3/2, just like the value of m is here. If they're both 3/2, that means that they're not going to cross each other. Now, assuming that this is the value of m, as in assuming that this is actually what m is here, the question is, what would the value of b have to be in order for the system to have infinitely many solutions? So infinitely many solutions mean that they're not just parallel lines, or they're not parallel lines in the sense that they are two separate that never touch, but that they are identical lines. They're equivalent equations. So for them to be identical lines, that means not only does the slope have to be the same, but so does the y-intercept. So b would have to be 4. All right, last question, question number 8. At the farmer's market, Kevin bought 5 apples and oranges, and he paid $12. The next week, he bought 7 apples and 3 bananas, and it cost $18. Use the system below to analyze the situation. Aha! So we have been given the system. This is not about can you write the equations, it's what can you do with them. Now it says, why are there no viable solutions to this system? Well, that's weird. Let's figure out how we would figure out the solution to the system. So we'd, looks like 5 and 7 aren't multiples of each other, 3 and 8 are multiples of each other. So I'm going to have to multiply them both by something. Well, let's just pick one. I'm going to eliminate the b's. So I'm going to multiply this one by 3 and this one by 8. I'm going to make it one of them negative so that they cancel out. So that means this is 15a plus 24b equals 36. That's the first one. And then multiplying by 8, everything. This is negative 56a minus 24b. There we got a plus 4 and a plus 24 and minus 24. That's what we're looking for. And then 8 times 18. 144. So that's negative 144. So that means I've got 36 minus 144 equals negative 108. And 15 minus 56 equals negative 41. So 108 divided by 41. So A equals 2.63. Kind of a weird number, but okay. So if A equals 2.63, that means, let's put that back into the equation. 5, that doesn't mean it's not viable though. Okay, so we're saying that apples cost $2.63 each. There must be some good apples, but that's not what makes it not viable. So let's figure out then what would B have to equal. Well, 5 times 2.63, so 5 apples, is going to cost 13.17. Plus 8B equals 12. Okay, so here we're getting into what makes this not viable. This is the cost of apples, right? And then we're saying plus 8 bananas equals 12. Well, we've already spent more than $12 on apples. So that means if I'm doing this right, that means that 8B equals negative 1.17. Bananas might be cheap, but it's about that. They're not going to be negative. So there's no viable solution system. Viable means that could actually make sense in the real world. So we'd say, look, there's no viable solutions because a price on bananas could not be negative. So this last question is going to be one it's going to ask you to actually think about the meaning of the answer, right? Why is it that there couldn't be solutions? And it's not saying that there's no numerical solutions. It's saying there are no viable solutions, as in the actual context suggests that a solution would have to have certain constraints, right? You have to have whole numbers. In some cases, you know, if it was like how many apples and how many bananas, if you got a 3.5 bananas, you'd say, well, it's not a solution because you can't have 3.5 bananas. You can't sell 3.5 bananas. And, or in this case, a price can't be negative. So that's what this last question is going to be doing, is going to be asking you to think about what does this scenario, how does that limit what actually could be viable answers? And what makes that not viable here is the negative. So you can't have a negative price on a banana. All right, that's the whole unit review. So good luck on that. If you need more copies, you can check your email because I'm going to be emailing this out for you to take a look at. I encourage you to practice this as much as you need. And of course, you've also got your exercise online for the Khan Academy stuff. And so good luck and work hard, and I'm sure it'll pay off.